All right, welcome to Session 8 Lab. Today we're going to be um, identifying and patching an anti-debug capability in malware. Um, I went ahead and I went through the lab, then took screenshots as I went through each step. So I'll go ahead and I'll talk through each. Um, we start off by being asked to unzip this vscoder.zip, which had a vscoder.exe within it in both our static and dynamic VMs. We started with our dynamic VM, in which we went ahead and performed a brief behavioral analysis by actually running the um, exe, and what we saw was that VS Coder kicked off and basically instantaneously terminated. Um, and it started up a kind of like a command prompt window, but that quickly closed, not long after executing. Um, and so um, what we can, um, just by seeing that behavior, we can kind of deduce that um, there may be some sort of mechanism that's preventing the process from running, um, maybe some sort of debugger check. When we actually do put that same exe into x64 debug, without running any breakpoints, we were able to see that it says terminated, debugging stopped. And then kind of going off of those two pieces of behavioral testing, we can suggest that there is most likely some sort of anti-debugging that is terminating the process. So we took that same exe into our static VM and we ran kappa against it. And after a few seconds, the kappa report came back with a few different seemingly anti-analysis functions. We can see there was a check for sandbox and antivirus modules, as well as a check for debugger via API, and a check for time delay via get tick account. Um, and so we focus specifically on the check for debugger via API. That's going to be at the 0x14000178 address. Um, in turn, that's also the sub 14001780 function. Um, and we took a look at that in Binary Ninja, and there were three Windows API functions that were being called within the code. Is debugger present? Check remote debugger present, and output debug string. Um, that those were all in that single sub 14001780 function. We went ahead and we renamed that um, into TB kappa anti-debug function, and you can see the function here. There's only one single reference to this function, and that was we took a picture of it here. Um, what we're seeing is the call to that function, a test of the return value of that function, whether it was a zero or non-zero value, and then you have this conditional jump, which will jump if that return does not equal zero. And so we deduced here that that I guess the logic is that it's going to check if this um, process is being debugged. If it is, or if the anti-debugger function returns a non-zero value, it will then go ahead and actually jump to this 0x140033CE function. Um, and so what we needed to really do was kind of reverse that condition to jump if equal to zero, so that our program can proceed running without being stopped by that is debugger present functionality. So you can see here, I moved it into x64 debug, and I actually patched this JNE, this jump not equal, into jump if equal. And then from there, um, I then set a breakpoint on create process A and ran. Actually, before that, I might have removed it. Oh, right here. Okay, so yeah, I had then, once I made that patch, I actually went ahead and I saved or patched the file. I saved the patch file as vscoder underscore patch.exe. And then from there, we loaded that back into x64 debug. We set a breakpoint on create process A, as you can see here. Um, and then I went ahead and I actually ran the debugger. And this time around, it didn't actually stop. It actually brought me to create process A, which means that we actually got past this is debugging present condition. Um, and then from there, I was able to actually um, get through to the uh, the main functionality of this malware. And I took a screenshot of that command prompt that we saw earlier that kind of exited immediately. And you could see here that it's actually running some shellcode execution. And you could even see it resolving some APIs and then finalizing with a shellcode decrypted successfully. So we were able to, one, validate that this malware is actually has anti-analysis debugging features. We saw that it crashed, or not crashed, we saw that it terminated. Uh, Went into the code, did some code analysis to see, and using Kappa to see um, where that functionality of anti-debugging is present. And we were able to kind of reverse the logic by patching in our debugger and then ultimately end up with our malware performing what it's supposed to do. All in all, very good lab, and yeah, that's all. Thanks, Anush.